Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in this video tutorial, we are going to be taking a look at another search algorithm which is known as binary search algorithm. So before we start off, in case you've missed the previous video tutorial, we discussed the linear search algorithm, which basically falls under the category of sequential search. So in linear search, what was happening is, let's say you want to search for the element x equals to 11. So you are basically starting off from the 0 index. You were checking the value 55, you are matching it with the x value, whether 55 is equal to x, which is equal to 11. Since this is not a match, then you are moving on to the next index position and so on and so forth. So you are hopping from one index position starting from the 0th position till you actually find the match, right? So this was linear search. I will drop the link of this entire DSA playlist in the video description. You can check it out. There are other topics in this playlist as well. And with that being said, let's get started with today's topic, that is binary search algorithm. Now we'll divide this topic in two parts. In this part, we will discuss what exactly is the binary search algorithm, the working and the algorithm. And we'll also take a diagrammatic representation and we'll take an example. And in part 2, that is in next video, after this one, we'll actually implement the binary search algorithm using C++ programming, and we'll convert the algorithm into actually the implementation part in a C++ code. Okay? So let's get started. Now binary search algorithm is basically an interval search algorithm. So it is a type of interval search and it is not exactly a sequential search. So when I say it is not sequential search, binary search algorithm does not go from one index position to next and in that linear fashion. Okay, so it does not check all the elements, but binary search algorithm is a type of interval search algorithm, and these algorithms are specifically designed for searching in a sorted data structure. So if you see, this array is not sorted in any order. It is not in ascending or descending order of the elements. But if you see, this is the same array, that is, it has all the same elements, but it is sorted in ascending order, starting from the lower value 7, then 11, then 55, 62 and 173 in this order, right? So binary search algorithm or interval search algorithms basically work on sorted data structures only. Now binary search falls under the category of interval search, and these type of searching algorithms are much more efficient than linear search, as they repeatedly target the center of the search structure and divide the search space in half. So of course we'll discuss in detail this line, but basically they are more efficient because they do not actually go one element to the next and to the next in a linear way. So they basically divide the structure or data structure into subparts and only search through that which is essential. And of course we'll see the working now. So let's go to the working of binary search algorithm. Okay, so as you can see on the left hand side, we have some description about the working of binary search algorithm, and on the right hand side I have a diagram. So let's say we have a sorted array of size 10. It has integer elements. You can see 1, 3, 12, 14, 23 and so on. So let's see how the binary search algorithm would work on this array. Okay, so the working of binary search algorithm goes as follows. We have to search a sorted array or sorted list basically by repeatedly dividing the search interval in half. Okay, remember this point. Now we have to begin with the interval covering the whole array. So the interval initially would be from 0 to 9, right? So the left value of the entire interval would be 0 and the rightmost value would be 9. Now if the value of the search key is less than the item in the middle of the interval, narrow the interval to the lower half, otherwise narrow it to the upper half. Now if you didn't understand this, we'll again go to this point, but let's just complete the working. And we have to repeatedly check until the value is found or the interval is empty. Okay, so let's assume you want to search for the value x equals to 75. Okay, so another way to put these 5 steps are as follows. So you have to compare x with the middle element. So for the first time, you have to calculate the middle element. So what you have to do is you have to take sum of left. So this is the leftmost value and this is the rightmost value, right? So you have to take a sum 0 plus 9 and divide it by 2. So you'll get 4.5, but obviously we don't have a 4.5 value index. We only have integers. We don't have fractional indexes. So we will just truncate this part. So we'll get 4. So right now let's consider this as the midpoint. Okay, so this is the mid. So you have to check x value with the middle element. So right now this is the middle element. The element at this index 4 is 23. So you have to check with 23 and compare it with the value that you want to find out. Now if x matches the middle element, we will return the mid index. So if there is a match, if 75 would have been over here, it would have matched with the value that we want to search, right? Then we would have simply returned this index position 4. That is, we found the value at index position 4. This is the output, right? But right now it is not matching, right? So next step is, else if x is greater than the mid element, if x is greater than the mid element, which is currently true, right? 75 is greater than the mid element 23, then x can only lie in the right half subarray. So essentially what we've done is we've divided the array into two parts, and this is the midpoint. So this is the first half, or you can also say left half, right? And this is basically the second half, or you can also say it as right half. Okay, so now we know that 75 is greater than 23, and we know that the array is sorted, which means 75 will be obviously lying in this half only, right? In the right half. So that is why this else if condition will be true. So now we will only search through the second half. We don't have to search through index position 0. We don't have to search through index position 1 or 2 or 3, because we already know that since 75 is greater than 23, our value 75, if it is existing in the array, it will always exist in the second half because it is a sorted array. And hence we require sorted array, and binary search algorithm only works on sorted array, right? So now for the next iteration, because we did not find the value at the midpoint, we will further carry out all the operations on this second subarray only. So again, we will calculate the mid. So for now, this is the new left, right? So we will say left is equal to mid plus 1. So the new left will be this one, and the right will be as it is. Okay. So let me just erase this all out. So as you can see, now we are only searching in the second half of this entire array, because we've concluded that since 23 was less than 75, we only have to search the right hand side. So now again we will calculate the midpoint. How do you calculate the midpoint? You take a total of 5 plus 9, you just divide it by 2. It would be 14 by 2. So you'll get the midpoint of 7. So now this is the midpoint. So this is a new midpoint. Okay, so this is the second iteration and we got a new midpoint. So now again we have to check the value at this midpoint, and we know that 65 is less than 75, right? Or you can also say 75 is greater than 65. So again, this statement will be again true. That is, x is greater than the value that we are getting at the midpoint. So now we will again know that we have to divide this small array into further more two parts. So this is going to be the first part, and this is going to be the second part, right? First and second. And since 65 is less than 75, we know that our value is going to be lying in the second half only. So now we are only interested in these three values, or these three index positions. So again we will search, and this process will keep on repeating till we actually find out the midpoint. Okay, so this was just the theory and working. And one last thing that I wanted to talk about is the idea of binary search is to use the information that the array is sorted, because obviously as we see, binary search algorithm will only work on sorted arrays, and the time complexity is reduced to O log n. Now we've not discussed about time and space complexity and those asymptotic notations, because I first want you guys to understand these different algorithms. So after we complete the searching and sorting algorithms, we'll take a separate look at the asymptotic notations and those different time and space complexity concepts. So if you're watching this video in the future, those videos might already be up in the DSA playlist. So do check it out. If not, definitely subscribe and turn on the notifications, because those videos will be uploaded soon. Okay, so this was just the theory on binary search algorithm, and I hope you've got a rough idea about how it works. Now let's take a look at the algorithmic statements and how the pseudocode would look like. Okay, so as you can see on the screen, this is the binary search algorithm in the form of pseudocode. Step number 1, step number 2. Inside step number 2, we have multiple steps, which is basically a loop, and then we have step number 3. Okay, so the first step states that we have to take input, we have to take the array, we have to take the left and right intervals, and the x value that we want to find out. So step number 1, take inputs written over here. We take the array ARR, so this is our array. Initially the left value would be 0, right? So this is left. Let me use another marker. And the right value is 9, which is the last index position. And let's assume we want to search for the value of 75, which is somewhere over here, right? This is that value. So we take the input. Now step number 2 is start the loop. And now the condition is while left is less than right. While this left index is less than the right index, it means that we have some interval, some values in between. So we have to keep on iterating this loop till left is less than equal to right. We have to divide this array into halves every time until and unless we find a match, right? This is how the binary search algorithm works. So this is going to be our condition. So for starters, obviously left is going to be less than right. Left is 0 and right is 9 right now. So this condition would be true. So we will go inside this loop, while loop, and we will execute step 2.1. Now at step 2.1, we are calculating the mid value, which is given by left plus right minus left by 2. So let's calculate that. Left is 0 plus right minus left, which is 9 minus 0. So 9 by 2. So this is going to give you 4.5, which is basically 4 because we don't have 4.5 index and we are playing with integers. So when you actually convert this into a program, this would be an integer value int mid. Okay. So it will only store the integer part and not the floating part. So now we've calculated the mid value. This is the mid value. So we move on from step number 2.1 to step number 2.2. So we are still inside the loop. This is basically our very first iteration. I'll write the iteration number over here. So in step number 2.2, we check if ARR of mid equal to x. So whatever the mid value we found out, index position, we check the value at that position, which is 23. We try to match it with our x value. X value is 75 and mid value is 23. So obviously this is not going to be a match. So this if condition will not be executed at 2.2. So we will move on from 2.2 to 2.3. Here we are checking else if ARR of mid is less than x. ARR of mid is 23. 23 is definitely less than 75. So this condition is true. So now we will execute this 2.3.1, which is inside 2.3. And here we are saying left is equal to mid plus 1. Left was 0 initially. Mid was this value 4. So 4 plus 1 will give us equal to 5. Okay. So now we just changed this left to value 5. So let's make that change over here. So the new left value is this index position 5. Now obviously the reason why we did this is we know that 23 is less than 75. So we know that the value 75 that we want to find out is obviously going to be to the second half of the array. So this is the second half and this is the first half. We divide it at this midpoint, right? So since 23 is less than 75, the 75 value is always going to be lying towards the right, that is the second half, because this is a sorted array. So that's why now we will only check between these two positions. So the interval has become smaller now. Okay, from 0, now the interval is between 5 and 9. And of course, after else if, we will come to the end. We will not execute step number 2.4 because this is the else part. So either if part, else if part, or else part will be executed. And since we just executed 2.3, we will not execute 2.4. We will come at the end of the loop. And now we will go at the start of the loop again. At the start of the loop, we will check while left is less than right. We just change the value of left and the new value of left is 5, right? We just got over here new value of left, which is 5. So 5 is still less than 9, right? Which means we still have some interval to cover. So again, the condition will be true. We will start with our second iteration. So let me just clear out the screen. So now we will again calculate the new midpoint. So midpoint is equal to left plus right minus left by 2. The new value of left is 5. You can see from the diagram over here. Plus 9 minus 5 is 4 by 2, which will give us 7. Right? So the new midpoint that we find out is 7. Coming to step number 2.2, we again check if ARR of mid equal to x. ARR of mid, which is ARR of 7, it is 65. Is it equal to 75? No, right? It's not. So this statement becomes false. So this if condition will never be executed. At this iteration, we will come to step number 2.3. Now we compare if ARR of mid, that is 65, is less than 75. This is true, right? So again, coming to step number 2.3.1, we again reduce the interval. We say left is equal to mid plus 1. We just calculated mid as 7. 7 plus 1 will be 8. So let's change that. So our new left would be 8. Okay. So obviously since 65 is less than 75 and this is the midpoint, we know that our value has to be somewhere in these index positions and not in these index positions, right? So we don't have to search for them in this and this part. We know that 65 is less than the value that we want to find out, so it has to be there in the last two values only. So that's why we again divide this subarray into more smaller arrays, and we are only interested in the second part of this subarray, right? So from step number 2.3.1 we will again come to the end. We will not execute the else part because we just executed the else if part. So from here we will again go to the start of the loop, and now we will again check while left is less than equal to right. The new value of left is 8. So you can see 8 is still less than 9. So again we will now start with the third iteration. Let me write it over here. Let me erase this out. Okay, so coming inside we again calculate the midpoint. Midpoint is given by left, which is 8. You can see index position 8 plus right minus left, which is 9 minus 8 by 2. So this would be 8 plus 1 by 2, which would give us 8.5, but ultimately we will truncate the floating point. So ultimately we will get the midpoint of 8. Okay. So now this is also our midpoint. Coming to step number 2.2, we will check if ARR of mid, which is ARR of 8, that is 75, is equal to our X value. Now our X value is also 75, right? So we want to search for that only. So we will get a match over here. So now this statement becomes true. So we will execute 2.2.1 in the third iteration. I mean, we will just return this index position mid, and this is where the algorithm will stop. So you can see that in 3 iterations we got our result and we got our match at this index position. Now if you see, if you would have started with linear search algorithm, what would have happened is in the loop we would have started from this position. We would have matched 75 with the index value of 0, which is 1. Then we did not get a match. We would have jumped to index position 1. Again, no match. So again jumping to the next, no match, jumping to the next, no match, and so on and so forth. So you can see the number of hops that we would have required is 1, 2, 3, 4, 5, 6, 7, 8, and at the 9th iteration we would have found our match. But using binary search we only required 3 iterations of this while loop. But if we would have used the linear search in the for loop, we would have required 9 iterations. So you can see binary search was much more faster, provided that we have a sorted array, right? So this is the power of binary search algorithm, and I hope you've understood the algorithm as well and the working with the diagram. Now in case if the search value that we wanted to search would have been somewhere over here, then first we would have calculated the mid. So let's say again we are at the first iteration only. Okay, so this is iteration number 1. Instead of x equals to 75, we want x equals to 3. So we would have calculated the mid. Initially this would be the left and this would be the right for the first time. We calculated the mid as 4, right, for the first iteration by using this formula, mid is equal to right minus left by 2 plus left. So that would give us 4. So now we would have checked over here if ARR of mid equal to x. So is 3 equal to x, that is 23 equal to the value that we want to find out, which is 3. Not true, right? Then we would have come to 2.3. We would have checked if ARR of mid is less than x. So ARR of mid is 23 over here. Is 23 less than the value that we want to find out, which is 3? Again false. So in this case step number 2.3 will not be executed, but step number 2.4 would have been executed. And here what we're doing is, since we know that 23 is greater than the value that we want to find out, if we divide this array at this midpoint, we know that we are having 2 halves. So this is the first half and this is the second half of the main array. But since 23 is greater than 3, we know that our value would be lying in the first half now, right? And not in the second half, because this is a sorted array. So now instead of changing the left value, which was happening at step number 2.3, here we change the right value, that is the right interval, and we say right is equal to mid minus 1. So mid is 4, so 4 minus 1 would be 3. So now this right interval would have changed and now it would point to this position. So now we are only interested in the first half and not the second half, okay? So this is that else condition. And of course then we would go with multiple iterations. This interval will become shorter and shorter until and unless we find our answer. And one last use case was, let's assume that we enter a number x equals to 115. Now 115 is not there in the array only, right? So in that case this interval will actually come to an end, wherein the while loop condition will become false and left value will become greater than right. In that case, this loop will exit out and ultimately we will return -1 at step number 3. So this step number 3 will only be executed when we do not find a match in the array, and when we return -1 in the program, we can determine that since we have returned a -1 and -1 index position does not exist, right? We don't have -1 index positions. So in the if else, we can check if the value returned from the binary search algorithm function is -1. If it is -1, then we did not find a match. And other than -1, if we get an actual value, then it would definitely be the index position of the value which is placed in the array. Okay? So this is why we've said return -1 over here, to indicate that we did not find anything matching in the entire array. So yeah, this was the complete working of binary search algorithm. I hope you've got a very clear idea about what exactly is binary search, how it works, the entire algorithm, as well as the diagrammatic representation. In the next video, we will implement this binary search algorithm using C++ programming, and things will be more clear on the implementation side. So that's it for this video, guys. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. If you have any queries, you can put them in the comment section. If you haven't yet subscribed, please make sure to subscribe so that you get notified whenever I upload the next video. And I'll see you guys in the next video. Peace.